Hello, good evening, everyone. I'm super excited to be here with you on this lesson for SS3 chemistry classes, where we get to talk about the continuation of naming organic compounds. So today is a continuation of the last class where we saw how to name hydrocarbons. So let's get into what we have for today's class. We saw alkanes in our previous class, and in today's class, we're going to be looking at alkenes. We've looked at the rules for naming organic compounds. So let's see if we can name some more organic compounds in today's class. All right, so we've looked at the naming of alkanes, and then let's move on to the next one, which is the naming of alkenes. So here is this example on the screen right now. Let's do some more examples with alkanes before we proceed. So we have this example on the screen right now. Let's accept or let's take all the rules step by step, and then let's see if we can get the names of these compounds on the screen. So first things first, we have CH3 being bonded to C, which has an H attached, and then we have a CH3 at the bottom over here. And then it is attached to a CH3 over here. This is what the entire structure looks like. So we are being asked to name this. So let's name it by following all the steps. First things first, identify the longest carbon chain. The longest carbon chain. So there are different ways we can count it. When we are counting carbon chains, we are counting the carbon atoms in a sequence. We can start from the left, which is over here, and go this way and go downwards. We can also start from the right, go this way and go downwards. That is another way. And we can also go straight all through, whichever way we choose. Let's see how many carbon atoms we can get as the longest carbon chain. So we have 1, 2, 3. That's the first way we counted. If we count this way, let's see how many carbon atoms we get. 1, 2, 3. So we have 3 carbon atoms. If we count this way, let's see how many we get. 1, 2, and 3. So the longest carbon chain we have are 3 carbon atoms. So we have 3 carbon atoms. That gives us the parent name. And the parent name for 3 carbon atoms is the name PRO. So let's just keep this in place. We'll need it later. So the next thing to do is to number the carbon atoms. We number the carbon atoms in such a way that the substituent will receive the lowest number. So we can identify the longest chain by counting from left to right or right to left, whichever way we choose. So we have 1, 2, 3, 3 carbon atoms. So now that we have 3 carbon we can see that over here there is a substituent, an alkyl substituent, CH3. And this CH3 is actually called methyl, a methyl substituent. So what do we do? The next thing to do is to locate and name the substituent. So this is methyl, and it is located on carbon number 2. So how do we name this substituent? We simply use the name 2-methyl. That is how the name will be identified, and that will serve as the prefix. So the next rule says to position the multiple bonds. In this case, we have no multiple bonds because there is no double or triple bond present in this compound. So there is no application of that rule to this case. It is peculiar. So the next thing is to combine the name, the prefix, the parent name, and the suffix. So the prefix is the name of the substituent. The substituent is 2-methyl. The parent name is the name assigned to the longest carbon chain, and we identify it to be 3. So we use PROP, prop, and then plus the suffix. It belongs to the alkane family, so we use the suffix ANE. So when we combine everything together, we end up with the name 2-methyl propane. Are you all with me? Beautiful. So that's how we name these compounds. So let's go ahead and see if we can name some more examples. Here is another example on the screen right now. We have this example on the screen right now. So let's apply the rule. So before we apply the rule, let's make this structure simpler because some people saying this might get confused. So we have CH3 bonded to CH2 bonded to C, this third C over here. It has an H attached to it, and then it has a CH3 attached to it over here. And then it has a CH2 and then a CH3. So this is the entire structure. First things first, identify the longest carbon chain. So how many ways can we count? We can count like this. If we do that, how many will we identify? We have one, two, three, four. Let's keep that aside, four carbon atoms. If we count all through straight, how many carbon atoms are we going to have? One, two, three, four, five carbon atoms. So we have five carbon atoms. If we count this way, how many are we going to have? One, two, three, and four. Four carbon atoms are what we're going to have. So the longest carbon chain is five carbon atoms. Five carbon atoms has the parent name pent. So let's keep that aside. Next thing to do is to number the carbon atoms. We number the carbon atoms in such a way that the one having the substituent will get the lowest number possible. If we count from left to right, this carbon atom over here carries a substituent. So if we count from left to right, we have one, two, three, four, five. The substituent will be positioned on carbon number three. But if we count from right to left, we have one, two, three, four, five. The substituent will still be positioned on carbon number three. So whichever way we count, either left to right or right to left, it is still perfectly fine. So identifying the substituent, it is a CH3, and the name assigned to CH3 is methyl. The carbon atom on which it rests is the third carbon atom. So to name it, we'll simply use 3-methyl. I'm sure you're seeing how everything is playing out. So the next thing to do is to combine the complete name or position the multiple bonds. In this case, we have no multiple bonds. Don't worry, we're going to get to the points where we have multiple bonds. Multiple bonds like double bonds and triple bonds. So in this case, we have no such thing. So what do? We move to the next rule that says combine the name, prefix, the parent name, and the suffix. The prefix belongs to the substituent, and the substituent is 3-methyl. The parent name, which is pent, and then the suffix, which is ane. Adding everything together, we have 3-methyl pentane. Did you see how everything is playing out? I'm sure you saw how everything is playing out. Yeah, thank you very much. Is it difficult? Absolutely not. So here is the third example on the screen right now. You can see this structure over here. So first things first, we want to have this structure broken down. We have CH3 bonded to a C, which is bonded to CH3, bonded to another CH3. Now, some of you might be confused thinking, why am I drawing two CH3 structures? Now, you can see at the end of the bracket containing the CH3, there is a number 2 here, which indicates that there are two atoms of CH3. So there are two atoms of CH3, and then finally, we have the last one. So this is the structure here. Let's name this. So first things first, how are we going to count the number or identify the longest carbon chain? We can count from left to right. If we do that, we have 1, 2, 3. So we have 3 carbon atoms. If we count from right to left, we have 1, 2, 3. Same number, 3 carbon atoms. We can count from the top to the bottom, 1, 2, 3. same number, three carbon atoms. Whichever way you choose to count, you end up with three carbon atoms. So the longest carbon chain, three carbon atoms, that gives us the name PROP, prop. And it's an alkane because we cannot identify any double or triple bonds in this structure. So we'll get to the cases where we have double bonds and triple bonds present, okay? But for now, let's stick with the cases with just single bonds. So the next thing to do is to number the carbon atoms. So remember, we are numbering it in such a way that the one that has the substituent will receive the lowest number possible. Now, if we're counting from left to right, for instance, we have 1, 2, 3. So this carbon atom over here, which has number 2, is the one that carries the substituent. So what are we going to do? On carbon number 2, we have not just one, but two substituents, and they are both CH3. So how do we name them? Here is what you do. You put the numbers of the substituents 2 and 2 because both of them are located on carbon number 2. And then the name that you give to them, since they are both the same, you use the name dimethyl. Dimethyl is simply telling you that there are two methyl substituents located on the carbon number 2. So this will serve as our prefix. Are you following? Beautiful. 2,2-dimethyl. We've identified the suffix. And then we know that there are no multiple bonds. And the prefix or the suffix now will now be ane since it's an alkane. So adding everything together, we have 2,2-dimethyl plus prop prop plus ane a. So altogether, the name becomes 2,2-dimethyl propane. Beautifully done. Beautifully done. So now that we have seen some examples of naming alkanes, the ones that have branches and the ones that lack branches, let's get into the concept of naming alkenes. So first things first, alkenes are unsaturated. Unsaturated simply means not fully filled. Okay, for example, here is an alkane having single bonds surrounding it all through. But in the case of an alkene, it has at least one double bond. And you can see there is a vacant space over here. In other words, it is not fully filled. That is why alkenes are called unsaturated hydrocarbons. Hello, good evening, and how are you?
Okay, sir,
Good
fine,
evening, David. You're welcome to today's class. How are you?
fine.
You're
Yeah.
just in time. We just finished talking about naming alkanes. So we're going into the concept of naming alkanes for today's class. Are you ready for what we have?
Yes, sir.
Beautiful. Can you see what's on the screen?
Yes, sir.
Good.
Nomenclature of alkenes.
Good. Alkenes. So do you remember what alkanes are from our previous class?
Alkenes are doubles bond.
No. Alkanes, not alkenes. We said in our
Uh,
previous class that alkanes,
Alkenes, okay. Okay, single bonds.
alkanes
I thought
are
it was one of the-
Okay, the names can be very tricky, so you need to pay attention. Alkanes are hydrocarbons that are saturated with single bonds in their entire structure. Do you remember?
Yes, sir.
And we saw how to name them. The assignment that I gave to you, did you do it?
Yes.
Good. I hope you're going to submit them in my DM once you're done with this class.
Yes, sir.
Beautiful. So in
Are you
this
talking
case,
about the SSC assignments?
no, I'm talking about the assignment I gave you for naming alkanes. I told you to name alkanes from number 1 to
Oh,
number
yes,
10.
yes, I've done it.
All right, good. So, in today's class, we're going to be seeing how to name alkenes. In this case, alkenes are hydrocarbons, unsaturated hydrocarbons that have at least one double bond in their structure. So we're going to be seeing what they are, what they mean, and how to name them. So their naming follows the same IUPAC rules. You remember the rules we saw in our previous class, is that correct?
Yes, sir.
Good. So the rules for naming alkenes are similar to the rules for naming alkanes, but in this case, we give special attention to the position of the double bond. Did you hear that?
Yes, sir.
Good. So let's see how to name alkenes in today's class. So first things first, we need to know how to identify the position of the double bond. How do we identify the position? Usually, when naming alkenes, the double bonds are shown or depicted by two lines like this, two lines between two carbon atoms. So this is what we call the double bond. Did you see that?
Yes, sir.
Good. So step number one, select the longest continuous carbon chain that includes the double bond. So what we simply mean is, if for instance, I have a carbon chain like this, 1, 2, 3, 1, 2, 3, 4. Now, I want to ask you a question, David. Can you see what's on the screen right now?
Yes, sir.
Good. Which chain is the longest chain? The longest
The
continuous
one
chain.
going down.
The one going what?
Down.
Down like this, right?
Yes.
What if I told you that there is a chain that is longer than that?
Uh,
If we start
okay.
counting from here all the way down, will it not be longer than if we just started counting down like this?
Yes.
Good. So what we are simply saying is, in the case where you have a double bond, instead of just counting, now look, if we count from the left downwards like this, we are not going to
It's
include this,
smaller.
we are not going to include this carbon atom that has the double bond. Did you see what I just did?
Yes, sir.
So the first rule is saying count the longest continuous carbon chain that includes the double bond. So any chain that we are going to count, it must include the double bond. We are going to count the longest, take note of those words, longest continuous carbon chain that contains the double bond. Are you with me?
Yes, sir.
Good. We're going to be seeing all the examples, so I don't want you to get scared, okay? So next rule says number the chain from the end that is closest to the double bond, not the substituents. Did you hear that?
Almost.
I said number the chain. That's rule number 2. Number the chain from the end that is closest to the double bond. Did you hear that now?
Yes, I heard it.
So, for example, now, let me redraw that structure that I drew. If I have C bonded to C, bonded to C, and then there's a double bond over here, and then this one comes down. You know, if I count from this point all the way to this point, the chain will still include this double bond, right?
Yes.
Good. But they said that we are to number the chain from the end closest to the double bond. So between this end and this end, which one is closest to the double bond?
The first one.
First one, this one over
Not
here,
the one
right?
that is going down.
Yes, that one is closer to the double
Yes.
bond. So that's what the rule is saying. We'll start counting from here. 1, 2, 3, 4, 5. That is how we are going to number the compound from the end that is closest to the double bond. And then the final rule says use the number to indicate the position of the first carbon in the double bond. Use the number to indicate the position of the first carbon in the double bond. So let's see some examples. Okay,
Okay.
good. Now you can see example number 1 over here. Look at this structure, David. This one over here.
Okay.
Can you see it? Can you see it?
Yes.
What's wrong? Is the network misbehaving from your end?
No, no.
Okay. So now let's redraw that structure and use these rules and apply it. We have CH3. Oh, sorry, that was CH2.
Oh, okay.
So let me rewrite it. CH2 bonded to CH bonded to CH2 bonded to CH3. So David, let's apply these rules and name this compound. What is rule number one?
Uh-huh. Select the longest continuous carbon chain that includes the double bond.
Good. So let's find out which one is the longest continuous carbon chain that includes the double bond. We already have only one chain. We can count either from left to right, or we can count from right to left. Is that correct?
Mm-hmm.
There are only
How do
two
you say?
ways. There are only two ways in which we can count in this structure, right? We can count from left to right, or we can count from right to left, right?
Okay.
Is there any other way to count apart from counting
Yes.
from left to right and right to left?
No, no
There's
that
no
way.
other. Good. So let's count. How many carbon atoms do we have? One, two, three, four. How many carbon atoms do we have?
Four.
So what is the parent name going to be?
I said four.
What is the parent name going to be?
Uh,
For four carbon atoms, David, what is the
uh,
parent name? Hello, David, are
uh,
you there?
uh, yes.
For four carbon atoms, what is the parent name going to be?
Four carbon. But
Thank you very much. BUT. So let's keep this aside, okay?
okay.
Well, it's going to be useful as we are naming this compound. The next thing to do is number the chain from the end closest to the double bond. So now we can count from the left or from the right to the left. One, two, three, four. Or we can count from the right, left to the right rather. One, two, three, four. Between this method and this method of counting, which one am I going to go with, David, based on this rule? Number the chain from the end closest to the double bond. Is it option one or option two?
Option two.
Why is it option two?
Because it's closest to the double bond.
Thank you very much. That is absolutely correct, David. And I'm so excited that you got that. So we're going to count from the left, one, to the right, two, three, four. Did you see that?
Yes.
Good. So now the third rule says use the number to indicate the position of the first carbon in the double bond. So between this guy over here that I just labeled and this guy over here, which one is the first carbon in the double bond?
Uh, Number one.
Number one, thank you very much. So what that simply means is that our double bond is on carbon number what?
One.
Thank you. That is what it means. It means our double bond is on carbon
One.
number. So how are we going to name it? We simply use the parent name, which is bot, and then we indicate the number where the double bond is one, and then the suffix. For alkenes, we always use the suffix N-E. So we have both one in. That is why the name is called both one in. Did you see that?
Yes.
Don't worry, I'll take another example. Look at this structure on the screen, David.
Okay.
CH3 bonded to CH.
Okay.
We have CH and then CH3. Now, let's apply the rules, David. Rule number one, select the longest continuous carbon chain that includes the double bond. So, what is the longest continuous carbon chain that includes the double bond? How many carbon atoms would that be?
4.
Thank you very much. Four carbon atoms. What would the parent name now be? Yeah, I'm waiting. What would the parent name now
So
be?
yeah, your voice is glitching.
Four carbon atoms, right?
So your voice is glitching.
Can you hear me? Hello, Dave. Can you hear me?
Oh, yes.
I was saying four carbon atoms are in the parent chain. So what would the root name or the parent name now be?
Uh, Boss.
BUT. Thank you. So
B.
now, what direction are we going to count or number the carbon atoms from? Would it be from left to right, or would it be from right to left? Which one?
Both.
Thank you very much. It will be either one, because if we count from here, one, two, three, four, the double bond will still be on this carbon number two and carbon number three. If we count from right to left, one, two, three, four, the double bond will still be on carbon number two and carbon number three. So you can see either we count from the left to the right or from the right to the left, everything will still be basically balanced. Are you with me?
Yes, sir.
Good. So I want you to follow me carefully. So let's number the carbon atoms. One, two, three, four. Now, David, rule number
4.
three, use the number to indicate the position of the first carbon in the double bond. So this is where the double bond is. We are counting from left to right. Which carbon is the first carbon that hosts the double bond?
2 or 3.
Which of them is the first?
The
Is it two or three? Which of them is the first?
2.
Good. We are counting from left to right. So that means the one that comes first, if we're counting from left to right, is this carbon number two over here. Is that correct?
Yes, sir.
Beautiful. So what that is simply telling us is that our double bond is on carbon number what?
2.
Thank you.
2.
So thank you very much. So when we are naming it, the name now becomes the parent name, which is boot, and then the position of the carbon atom, which is number two, plus the suffix, which is in, and then we have both two in.
Mm.
Are you clear?
Yes, sir.
Beautiful. So that is why all of this have these names, both one in and both two in. So now, all these names that we just did, all these compounds that we just named, they didn't have any branch. You see that all of them were just straight chain alkenes. One, two,
Mm.
three, four. There was no branching of any carbon atom like the way I have over here. All of them were just basically straight, right?
Yes, sir.
Good. So we want to see cases now where the alkenes have branches. So how do we do that? First rule says identify the parent chain with the double bond. Are you with me?
Okay.
Good.
Yes, sir.
And then next rule says number the end that is closest to the double bond. Are you with me?
Yes, sir.
And then third says name and number the substituents the way you did in alkenes. Don't worry, I'm going to show you an example. Don't be confused, okay?
Okay, sir. Okay.
Why are you shouting?
Okay, sir.
Why are you shouting?
No, nothing.
Okay. So now look at this example on the screen right now, David. Let me redraw it. So we have CH2, right?
Yes, sir.
And then a double bond. Then we have CH, and then single bond. Then we have CH. Now you can see this one over here in a bracket. Do you know what it means?
No.
Anyone you see in a bracket is a branch or a substituent. Are you there?
Okay.
Good. So what we're going to do to a branch is that we're going to draw it. We can draw it either down or up, whichever one we choose. Okay. So this is the branch, CH3. So the next one is CH2 and then CH3. Do you understand how I drew this structure? Or
Yes.
should I do it again?
I understand for you. Do it again,
All
please.
right, I'll do it again. Don't worry. I'm here to help you, okay? So let me redraw the structure. Number one, I have this one over here, CH2, right?
Mm-hmm. Yes, sir.
Let me draw it. C and then H2 means two hydrogen atoms. These are the two hydrogen atoms. Did you see that?
Yes, sir.
And then a double bond. Did you see that? This double bond over here.
Yes, sir.
And then I have
Yes, sir.
C. How many H does that C have? This one.
One.
Good. So I've drawn the one. So what is next now?
And then a single bond, then
Yes.
another carbon atom.
Good. Then that carbon atom, what does it have? It has an H,
One
right?
H.
Good. Let's draw it.
Yes, sir.
And then there's a bracket here, right?
Yes, sir.
Good. That bracket is telling you that that is a branch. So that branch is going to come under here. Did you see that?
Yes, sir.
So we have, what is inside the bracket? CH3. Did you see that?
Yes, sir.
So what is next?
Another single bond,
Mm-hmm.
then
Then what?
a carbon atom
Then what?
with two hydrogen atom.
Okay, I've drawn that. What is next?
Another single bond with a
Mm-hmm.
carbon atom.
Mm-hmm.
Then three
One,
hydrogen
two,
atoms.
3. Did you see how I drew the structure?
Yes, sir.
Beautiful. So the next thing to do is to identify the longest carbon chain. So David, there are different ways we can count this thing. We can start counting from here. 1, 2, 3, 4, 5. That is one way of counting, right?
Yes, sir.
We can start counting
Uh,
from here and we'll go down. How many carbon atoms are we going to get? 1, 2, 3, 4, right?
yes, sir.
Beautiful. So now my question to you is, what would the longest carbon chain be? Which direction are we going to count that will get the longest carbon chain?
Still the one with the double bond.
Mm-hmm.
Mm, I think the one is four.
Are you sure?
Yes.
If we
No,
can,
wait.
okay.
No, it's five, five.
Okay, where did you count from? From left to right or right to left?
Left to right.
Okay, so we counted from left to right. So doing that, we have 1, 2, 3, 4, 5, right?
Yes, sir.
5 carbon atoms. What is the parent name going to be?
Pent.
Thank,
P-N-T.
thank you very much, David. Thank you very much. This is what I want. Pens, beautiful. So the next thing to do is number the carbon atoms. Now, remember, we are numbering the carbon atoms in such a way that this our double bond will receive the lowest number possible, right?
Yes, sir.
Good. We can start numbering from left to right. One, two, three, four, five. Or we can start numbering from right to left. One, two, three, four, five. Which way are we now going to pick? Between left to right or right to left?
Left to right.
Thank you very much, because this our double bond needs to receive the lowest number possible. So let's number from left to right. We have one, two, are you following? Three,
Yes,
four,
sir.
and five.
4, 5,
Good.
6,
Where is six coming from? We have only just five in the longest continuous chain.
I don't say 6.
Okay, I thought you said six. Now, the next thing I want to ask you, David, is do we have any substituent or any branch in this compound?
Yes.
Where is it?
Yes. The CH3 that is
Very
going down.
good. This is it, right?
Yes, sir.
So my substituent now is a CH3. CH3, what is the name?
CH3 is propane.
No, CH3 is methyl. That is the name. Did I teach you names of
Meth-
substituents?
Nasal substance. No.
Okay, 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 okay. So in this case now, the substituent we have is a CH3. CH3, when it is a substituent, it is called methyl. Are we cool?
Yes, sir.
Good. So the next thing to do is, the next question I want to ask you is, which carbon atom has this methyl attached to it? Is it carbon number one? Is it carbon number two? Is it carbon number three? Is it carbon number four or five?
Number 3.
Thank you very much. So if I want to name this
No.
substituent, I will use the number that has it, which is three, and then I put a dash and write the name 3-methyl. Did you see how I named it?
Yes.
Good. The next thing to do, remember we are following it step by step. We have identified the longest carbon chain. We've numbered the carbon atoms. We have located the substituent and we have named it. Now, the position of the multiple bond. Is there a double bond in this structure?
No.
Are you sure?
No. Wait.
Over here, is there a
The
double
entire
bond?
structure is, yes, there is. I thought you were talking about the one-sided missile.
Okay, no, no, no. I'm talking about in the entire structure. Remember, we're on step number four,
Okay,
which
okay,
is the
yeah.
position of the double bond. So there is a double bond now. Which carbon atom owns that double bond?
Huh?
Which carbon
Not hear the
atom?
question, please.
Which carbon atom is carrying the double bond?
The first carbon atom.
Thank you very much.
The
So
letter
the
number 1.
first carbon atom, number one, and then the double bond, E-N-E. Remember, alkenes always have the suffix what? E-N-E, right?
Yes, sir.
Good. So I'm showing you the position of the carbon that has the double bond, which is number one. So let's indicate it number one, and then the suffix will now be E-N-E. So at this point now we'll combine everything together. The prefix is the name of the substituent, and we have named the substituent to be 3-methyl. Is that correct?
Yes, sir.
Then plus the parent name. How many carbon atoms did we count?
Mm, 5.
Good. That
10.
is Pent. Thank
E-N-T.
you. Thank you. Then plus the suffix now. What did we write as the suffix?
E-N-E.
Yes, 1 E-N-E. Don't forget this number one. It is telling you the position of the double bond. Are you there?
Oh, okay.
Yes, remember when you want to write the E-N-E, you always indicate the position of the double bond. So now, altogether, we have the full name 3-methyl, right?
Yes, sir.
Pent 1-ene.
Mm.
Did you see how I named this?
Uh, yes.
Don't worry, I will still take more examples. I don't want you to be confused, okay? Look at this example over here.
Oh.
Or let's do this first
Ooh.
one. Should we do this one or should we do one of these ones that have been given as assignments?
Let's do the ones that is not giving an assignment.
This one over here, right?
Yes, sir.
Okay, good.
But first, I have a question.
Yes, what's your question?
Uh, you said the the suffix for alkenes is ene, sir.
Yes, for alkenes is E-N-E.
Yeah, I've forgotten what alkenes are.
Alkanes is A-N-E. In. Then for alkenes, E-N-E. In. Can you see the difference?
Yes, sir.
Are you clear now?
Okay. Yes, sir.
All right, so I was telling you about substituents. So here is the first one. When you see a CH3 that is not part of the main chain, you call it methyl. When you see a C2H5 that is not part of the main chain, what is the name you can see here?
Ethyl,
Yes, ethyl. And then when you see a C3H7 that is not part of the main chain, what is the name you call it?
propyl.
Good. So I brought this one in because we're dealing with one example that has a branch. So let's name this compound. So can you see the compound on the screen right now?
Yes, sir.
Beautiful. So David, let's take this step by step, okay? Now, let's redraw this structure in a way that you can understand. This is the first one, right? CH3.
Yes, sir.
Good. Let's draw it. CH3. One,
Two,
two, three. Are you with me?
three.
Beautiful.
Yes,
What
sir.
is the next thing?
A single bond,
Mm-hmm.
then a carbon atom,
Good. A carbon atom. What is joined to it?
a branch.
Good. Thank you very much. I told you that when it's in a bracket, it is a branch. So let's draw the branch. It can be up or down, whichever one we choose. So what is that branch?
Two carbon atoms and five hydrogen atoms.
C2H5, right?
Yes, sir.
Good. Whichever way we can draw it like writing C2H5, and we can also draw it like this since it's two carbon atoms, C, then five hydrogen atoms, 1, 2, 3, 4, and 5. Did you see how I drew it?
Yes, sir.
But in order for us not to be too confused, so let's just draw
Hmm.
it as C2H5. Have I lost you?
Okay, sir. No, sir.
Are you sure you understand?
Yes, sir.
Good. So what is next now?
We add a double branch.
A double bond.
A double bond, sorry, sir.
Then what is next after the double bond?
One carbon atom and one hydrogen atom.
Thank you. One carbon atom and it has one hydrogen atom. What is next?
A single bond
Good. Then after
with
that,
one carbon atom and two hydrogen atoms.
good. So here is the first hydrogen atom. Here is the second hydrogen atom. What is next?
Another single bond
Mm-hmm.
with again one carbon atom and two hydrogen atom.
Good, good. Then what is next?
In a single bond,
Good.
then one carbon atom and three hydrogen atom.
One, two, three. Beautiful. We have redrawn the structure in a way that even the most uninitiated novice can understand. Are you with me?
Yes, sir.
I'm so excited that you're following every bit of this, David. Thank you. So now, rule number one says what?
Identify the longest carbon chain.
So, David, I want to ask you, what is the longest carbon chain in this case? Look at it for me and tell me.
Six carbons. The one and it starts from left to right.
Okay, six carbon atoms. What would the parent name now be?
Hex.
Thank you very much. Hex. Now, let's keep this aside. We are going to need this parent name later on. Are you with me?
Yes, sir.
We have done step number one. Step number two, number the carbon atoms. Now, David, I want to ask you, where are we going to start numbering the carbon atoms from, rather?
Left to right.
From left to right or from right to left?
Left to right.
David, hold on. Let me redraw the structure again because I think we have missed out something. Because I don't think the
Oh.
longest carbon chain is six. I think it is more than six. Now, watch this. This is the
Oh.
first carbon atom, CH3, right?
Yes, sir.
And then it is bonded to C, right?
Yes, sir.
Good. And then that C has this C2H5, right?
Yes, sir.
Let me draw it. One, two. And then this is the H. One, two, three, four, five. Is that correct?
Yes, sir.
Good. What is next? A double bond, right?
Yes, sir.
And then we have CH, right?
Yes, sir.
And then we have CH2, right?
Yes, sir.
And then we have another CH2, right?
Ye- Yes, sir.
And then we have CH3, right?
Yes, sir.
Now, David, look, we can start counting from left to right. One, two, three, four, five, six. Is that correct?
Yes, sir.
Good. And we can start counting from this point over here that I just labeled. And we can go like this. Is that
Oh,
correct?
I didn't
Remember,
know. Oh,
remember,
okay.
we are counting the longest continuous chain.
Okay. Hmm.
Are you with me?
Hmm. Yes, sir.
Remember, the rule says the longest continuous. Are you confused?
Mm. No, sir.
Okay, let me redraw the structure for you again. This is CH3, the first one over here, right?
Yes, sir.
Good. And then the next one we have C, right?
Yes, sir.
Good. And then this is the branch, C2H5. Let's draw it. One carbon atom,
Mm.
two carbon atoms, right?
See. Yes, sir.
How many hydrogen atoms?
Five.
One, two, three, four, five. Are you there?
Yes, sir.
What is next now?
Double bond.
Thank you. So I have CH, CH2. CH2, and then CH3. Are you with me?
Yes, sir.
Good. Look at this guy over here. It is a carbon atom with two hydrogen atoms. Is that so?
Uh, yes, sir.
So I can just write CH2. Is that also correct?
Yes, sir.
Good. And then over here, I have a carbon atom with three hydrogen atoms. So I can write CH3 as well. Is that correct?
Yes, sir.
Beautiful. So now, David, I want you to observe with me. There are different directions that we can start counting from. If we start from this point that I just labeled, did you see that?
Yes, sir.
Good. I can go left. If I come to this junction, I can also go up, right?
Yes, sir.
Good. At this junction, what direction can I go again?
Right.
Thank you. So if I move right, is that not also a direction of counting?
Yes, sir.
Good. So how many carbon atoms if I follow that direction? Let's count now. One, right?
Yes, sir.
Two, right?
Yes, sir.
Three. What's next?
3,
Four,
4,
five,
5,
six.
6,
And then what?
7.
How many carbon atoms did I count?
7.
Beautiful. If I count from this direction over here, I go left. At this junction, where can I go now?
Down.
Thank you. If I go down, what direction can I go now?
Right.
Good. I can go right. How many carbon atoms? One, two, three, four, five, six, and seven. David, I want to ask you honestly, are
Yes,
you
sir.
are you confused?
No.
Are you
I
sure?
understand now.
Are you sure?
Yes, sir.
Remember, we are
Yes,
counting
sir.
the longest continuous carbon chain that contains this double bond. Are you with me?
Yes, sir.
The meaning of that rule is if we count a carbon chain that has six carbon atoms, but it contains the double bond, and then we count the carbon chain with seven atoms, seven carbon atoms, but it doesn't contain the double bond, we are going to go with the one with six carbon atoms that contain double bond. Did you understand what I just said?
Yes, sir.
Beautiful. So now we have identified the longest carbon chain, which is seven. Are you there?
Yes, sir.
What would the parent name now be?
Hex. I
Nope.
mean, Hex.
Thank you. Hept. Are you there?
Yes, sir.
Good. So the next thing is to number the carbon atoms. Remember, we are numbering the carbon atoms in such a way that this double bond will receive the lowest number possible. Is that so?
Yes, sir.
Good. So what direction are we going to start counting from?
From the branch.
Okay. So I have over here CH2 and I have over here CH3. Is that correct? So
CH3.
am I going to start counting from right
Yes, sir.
and then I'll go down and come here? Or I'm going to start counting from here and then I'll go up and come here. Where am I going to start counting from? Option one or option two?
Mm. Option 2.
Thank you very much. Because that is the part that gives the lowest possible number to the double bond. So for option two, I have one, two, three, four, five, six, seven. Did you see how I did that? No.
Mm.
Did you see how I did that?
Yes, sir.
Beautiful. So now my next question to you is, what number is the double bond on? Which carbon atom is carrying the double bond? Is it one, two, three, four, five, six, or seven?
3.
Thank you very much, David. Thank you. Thank you. Three. So how do we name it? We use the number three and then put our dash ENE. Did you see that?
I can't hear you.
The carbon atom that is carrying the double bond
I
is on.
can't hear you.
How about now? Can you hear me now?
Yes, sir.
Can you hear me clearly now? Clearly.
Yes, sir.
Are you sure you can hear me clearly now?
Yes.
Beautiful. I was saying the carbon atom that has the double bond is number three, right?
Yes, sir.
So to name it, we're just simply going to use the number three with our dash and then ENE. This name is telling us that the double bond is on carbon number three. Did you get that?
Yes, sir.
This is what is going to be our suffix.
Mm. Okay, okay.
Good. So the next thing now, we have numbered the carbon atoms. The next thing is to locate and name the substituents. Now, David, this we have counted our main chain. Is there any branch or substituent? I want you to look very well and tell me.
Which one?
This whole structure now, we have counted the number of carbon atoms, right?
Yes, sir.
And I told you that, don't worry. I told you that anyone that is not part of the main chain is a substituent or branch, right? Do you remember that?
Yes, sir.
Good. So now I'm asking you, is there any branch in this structure? Look closely and tell me.
Yes, sir.
Where?
Is CH2 and CH3 that is going down.
Are you sure? Remember, I said if it is not part of the main chain, if it is not part of the main chain, then it is a branch. This CH3 and CH2, are they part of the main chain?
Yes, they are.
Good. So they cannot be a branch. So I want you to check very well. Is there
The
anyone?
CH3 that starts at the left.
Good. This one over here, right?
Yes, sir.
Beautiful. It is not part of the main chain. So this guy over here, automatically, it will become a branch. Did you see that?
Mm. Yes, sir.
So how do we name the branch now? The branch is CH3. What is the name given to CH3?
Methyl.
Thank you very much. Methyl. Which carbon atom is carrying the CH3?
The first one.
Which one? Look at it. Look at it. Which carbon atom? Is it one, two, three, four, five, six, seven? Which carbon atom is it attached to? The methyl. Which
Is
carbon?
attached to 3.
Eh?
Is attached to 3.
Thank you very much. It is attached to carbon number three. So how we are going to name it is we put the number three, then our dash, and put the
I
name.
can't hear you. Can't hear you.
Can you hear me now?
No, wait, can't hear you.
Can you hear me now?
Yes, sir.
Are you listening to me directly from the speaker of your phone or with earpiece?
Directly.
I think that's why. I think you should use an earpiece next time, okay?
Okay.
All right, no problem. So we were saying that this is the branch. Is that correct?
Yes, sir.
Good. And the branch is on carbon number three. Is that correct?
Yes, sir.
And the name of the branch is methyl. Is that also correct?
Yes, sir.
Beautiful. So how we are going to name it is we put the number three with a dash and then we put the name methyl. Did you see that?
Yes, sir.
This is now what is going to be our prefix, 3-methyl. Do you
Okay,
see?
sir.
Do you see how I'm breaking it down?
Yes, sir.
Good. So now,
Very.
the position of the multiple bonds, we have done that. The double bond is on carbon number 3. We have done that. So now, what is the next thing? Combine the name. So what is our prefix now? 3-methyl, right?
Yes, sir.
Plus the parent name. What is the parent name? Hept, right?
Heptene.
Good.
Heptene, sorry.
Hept. And then our suffix 3ene. Did you see that?
Yes, sir.
So let's join everything together. We have 3-methyl hept. Hept what?
Heptene. E-N-E.
Hept 3-ene. 3-methyl hept
Heptene.
3-ene. Wow. Did you see that?
Yes, sir.
Don't worry, David. This class is being recorded, okay? So once we're done, I'm going to upload it to my YouTube channel and I'll drop the link so you can go and watch every bit of what we did. Are you cool with that?
Uh, okay.
Good.
Okay.
So
Yes, sir.
here are some assignments that I want you to do from number 1 to number 5. Can you try them for me?
Okay.
Good. I want you to look at the rules that I stated in the video of this lesson and then name them for me. Go ahead and write them down and then we'll close for the day.
Okay, sir.
Go ahead. I want to say a very big thank you for logging in today's class with me. It's been a pleasure showing you how to name alkenes.
I can't hear you.
I say I want to say a very big thank you for logging in on today's class with me. It's been a pleasure showing you how to name alkenes. So have you written it down?
Still writing.
You're still writing, or you write it down quickly.
Yes, sir.
When you're done, let me know.
Okay, sir.
Are you done now?
Okay, so I'm done.
Beautiful. So thank you for
Yes, sir.
logging on to this class. I'm looking forward to the first assignment that I gave you to name alkenes from carbon number 1 to carbon number 10. Submit it immediately this class is over to my WhatsApp DM, okay?
Okay. There's
All
no
right.
website.
No, 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 I'm not dropping the link. Write it in your notes, snap it and send it to my WhatsApp
Uh,
DM.
sir, can you hear me?
There is no link. Snap it and send it to me on WhatsApp.
No.
All right, bye-bye.
Okay. Bye.